We're going to use the vertex form of the quadratic equation to actually solve certain problems. Okay, and so again, we're always looking at equations in the form of the vertex form. So in the form of y equals a x minus h squared plus k, where hk represents the vertex. So in this first example here, we have a construction worker who gets frustrated and drops his wrench. Okay, it's going to fall. As it falls, its relationship is modeled by h equals negative 4.9 t squared plus 342. Okay, where h is the height above the ground in meters, and t is the time after the wrench was dropped in seconds. Okay, it's very important to note that it represents after the wrench was dropped. Okay, so we need to sketch a graph. It doesn't need to be 100% accurate, but why do we only need one particular graph? Well, this is going to represent height. Okay, probably a building. Okay, the guy is probably standing in the building somewhere. Okay, so let's say this is the building, and here is the poor individual who has lost his wrench. Okay, and so his wrench, he drops it, and it's going to fall all the way to the ground. Okay, so we don't need the other half of the parabola. We only need one part of it. And so this section here represents the ground. Okay, and then up here, and so we'll have time, and this is height. Okay, so we want to first identify again our AHK values for this particular parabola. Okay, so given the equation that's right here, can we identify our AHK values? Well, our A value is actually going to be negative 4.9. Okay, and so because our parabola is actually heading down, that means that the uh, the A value must be a negative number. The H value, there is no H value, and the K value is actually going to be positive 342. So based on the knowledge that we have here from the AHK values, we can figure out what the vertex is. Again, our vertex is the HK value. So our vertex is actually going to be at 0, positive 342. Okay. The direction of opening, because the A value is negative, we know that it's going down. Okay. I'll come back to this idea of why we only need one quadrant up here, and that's because we're really trying to figure out both time and height, and you can't have negative time and you can't have negative time or negative height. Okay, so you cannot have negative time or negative height. Okay, the wrench isn't going to fall, 300 meters into the earth or anything like that. Okay, so we can also figure out what the step pattern is going to be because we know what the A value is. So in order to figure out the step pattern, we could do y1, y2, the x piece. So 1, 2, 3, 1, 4, 9. And so you would just multiply 1 times negative 4.9, 4 times negative 4.9, 9 times negative 4.9. Okay, so that's how you would get the step pattern. But we can also use the equation to figure out information using straight algebra. Okay, and so we want to know right off the bat was how far above the ground was the wrench when it was dropped. Okay, so we know the equation is y is equal to negative 4.9 t squared plus 342. Okay, and so when it was first dropped, how much time has actually passed? Okay, so what's the time value? Well, when the wrench is first dropped, at the very moment, again, t represents the amount of time the wrench has been falling. When t has been falling at all, it's been falling for 0 seconds. So we can actually substitute in 0 for t. So that means that y is going to be equal to negative 4.9 times 0 squared plus 342. Okay? Well, 0 squared is 0. So negative 4.9 times 0 plus 342. Negative 4.9 times 0 is actually 0. In fact, any number times 0 is 0. So we're left with y is equal to 342. Okay, so what it means is that the height of the wrench when it was first dropped is at 342. Okay, so this here is going to represent, right there, it's going to represent the vertex. And my graph has shifted a little bit, but uh, he's dropping it at the vertex. The next question there says, how far has the wrench fallen after 5 seconds? Okay, well, we know that from the equation, okay, where we've got height, okay, so the height is equal to negative 4.9 t squared plus 342. That's the equation that we're given. We want to know how far it's been falling after 5 seconds. Well, if we want to know how far it's been falling for 5 seconds, that equals the time. Okay? So 5 seconds represents the time that it's been falling for. So we're actually going to substitute in 5 for t. So h is equal to negative 4.9 times 5 squared plus 342. Okay? So h is equal to negative 4.9. 5 squared is 25 plus 342. So we're using our BEDMAS skills here. Okay? So if we go through and we use BEDMAS, we can figure this out. Okay, so we've done our exponents. Now we're going to do our multiplication. So 5 times negative 4.9 is going to be equal to negative 24.5 plus 342. So h is going to be equal to 317.5. Okay, so the wrench has fallen 317.5 feet after 5 seconds. If we continue on, we want to try and figure out, well, how far has the wrench then fallen after 10 seconds? Actually, before we do that, I realized that I made a mistake. I need to go back and correct this piece, because clearly, when I multiply 25 times negative 4.9, I get negative 122.5 plus 342. So after 5 seconds, the wrench has fallen 219.5 feet. That is the correct way of looking at it. So now we're going to try and figure out, well, how far has the wrench fallen after 10 seconds? So same idea, okay, because we have to identify, we know if it's been falling for 10 seconds, then that means that 10 represents our t value. Okay, so let's try and figure this out. We have h is equal to negative 4.9 t squared plus 342. So h is going to equal negative 4.9 times 10 squared plus 342. So h is going to equal negative 4.9 times 100 plus 342. H is going to equal negative 440 And 90 plus 342. So negative 490 plus 342 is equal to negative 148. Okay, so after 10 seconds, the wrench has fallen negative 148 feet. So does this make any sense? Well, is it possible to fall a negative distance? No, it does not make sense. So when the wrench actually hits the ground, it's going to stop falling. It's not going to fall 148 feet into the earth. Okay, so uh, as a result, it's got to be, it has to fall for somewhere between 5 and 10 seconds is going to be the final amount of time that it has actually fallen for. So now let's figure out what that final amount of time is. So when will the wrench actually hit the ground? So if we want to know when it hits the ground, the key question here is, well, what's the height? Okay, and if it hits the ground's height is represented by 0 feet. The ground is at 0 feet. So let's go through and use our equation to figure out how far this actually is. Okay, so we're trying to figure out the t value. So we know h is equal to negative 4.9 t squared plus 342. So what we're going to actually do is we're going to use reverse Bedmus to isolate our t. So we're going to go in reverse. So we're going to look to see if there's any addition or subtraction that we need to get rid of first. So we actually have some addition to get rid of. We have some multiplication to get rid of, and then we have some exponents to get rid of. So what I'm going to do is I'm actually going to write this out and substitute in my value for h. So 0 is equal to negative 4.9 t squared plus 342. So what I need to do now is actually move this positive 342 over to the other side. So that means that I need to subtract 342 from both sides. So 0 minus 342 is negative 342. And that piece stays the same. Positive 342 minus 342 is going to equal 0. Okay, so we've moved all of the addition stuff to the left-hand side of the equal sign, okay, by subtracting both sides. So now what we need to do is we need to deal with the multiplication. So the opposite of multiplying is dividing. So I'm going to actually divide both sides by negative 4.9. So if I take negative 342 and I divide it by negative 4.9, that's going to give me approximately, and I'm going to use 68 is equal to t squared. Okay, and then I'm going to find the square root of that to equal approximately 8.4 seconds. Okay, so time is going to equal approximately 8.4 seconds. So the wrench is going to hit the ground about 8.4 seconds after it was dropped.